Hello and good morning. It is the Miss Peg up bright and early to help out with today's lessons. We are looking at relations and functions. We're in chapter 4 of our Algebra 1 book here in Alachua County District. So we're going to jump right into this. It says monitoring progress and modeling with mathematics. This is our practice page for chapter 4, 3.1. I'm sorry, chapter 3. So we're in section 3.1. And we're on page 108. So if you want to follow along, feel free to follow along. Maybe this lesson will help you get some understanding on determining the difference between relations and functions and how they look. There's a few different ways that we write relations and functions. One that can be written as a set of ordered pairs. Let me see, my pen is here. So here we have a set of ordered pairs. Here we have some mappings, and here we have tables of values. On this side, we have graphs, and over here we have points that are plotted, and more graphs. Okay, so those are different ways that you're going to see relations and functions in class or on any of your tests, so you have to first identify what is it that you're looking at. Second thing you have to do is look at the directions. So it says here in exercises 3 through 8, determine whether the relation is a function. So the first thing to note is that they're all relations, but some of them may or may not be a function. And so here's what that means. Every one of your x values can only be paired with one y value. And let's figure out how to determine this. When I look at it in a set of ordered pairs, I'll see all my x values are the first terms. The first numbers here in the points. And a very good way is to create a mapping out of this information. So I say 1, 2, 3, 4, and 5. Those are all of my x values or my domain. So what are my y values? Are any of my y values duplicated here? Not really. 1 goes to -2. 2 goes to 1. So he just goes to one y value. 3 goes to 6. That's one y value. 4 goes to 13, and 5 goes to 22. So this one was very easy to see, that each x is only pointing towards one y value. So yes, that is a function. So let's take a look at this next one. So I guess the first key you would look at is, are there any repeated? So here we go, 7. Let's just start here. 7, 5, 3, 1. And then I have a repeat of a 3. 3 is already on my list, so I'm going to leave that. Okay. Now here, 7 goes to 4. We have a -1, a -8, and a -5. So 7 goes to 4. 5 goes to -1. 3 goes to -8. 1 goes to -5. But we had that additional 3, and that additional 3 went to a 6. So because that additional 3 went to 8 and to 6, that is not a function, because remember, x can only be teamed up with one y. Okay? It actually can go the other way. One y can team up with many x's, but it doesn't work in the forward. So one x cannot go to many y's. So this is no function. Function, no function. There we go. So that's what that looks like. That's how you would handle that on a test. Don't assume you know what you're talking about when you see it. If you see a 3 and you see a 3, if you see a same number in your X column, that might be a giveaway. Okay? All right, moving on to the mapping. So what I did here is I kind of created a pseudo mapping. I just kind of made it a fast like shortcut way to do my mapping. So normally you're going to do a mapping with these ovals that you see here that we're about to work with. I just kind of write it out to the side because I like to take shortcuts only when it matters the most. Okay, not in the actual calculating. All right, so here, input and output, we're looking at the same thing, but we have less work. Yay! So now we just have to see what are we looking at. If you can determine what you're looking at, then you already know the answer to the question. So again, the same direction, say determine whether the relation is a function. Well, every x value can only go to one y, so that works. That works. That works. But look at this 2 also goes to a 2. He goes to 2y's. This is not a function. Okay, coming over here, let's see. This 10 goes to 1. That works. 8 goes to 1. Notice they both went to the 1, but the 1 was in the y, so that's okay. Negative 6 goes to 2. Negative 4 goes to 2, because negative 4 still is only going to one place. And negative 2 goes to 2. This is a funny looking one because in our mind we're thinking that we can't have multiple numbers pointing to another number, but it's only the x values that matter. And here, all the x values are only pointing to 1. So yes, this is a function. Okay, and here, looking at the last way, I want to show you a trick that I use very often. So this is not showing us a table up and down like I was making off to the side. This shows us a cross. This is a horizontal table. So my x is on the top, and the first thing I'm going to do is notice I have a 1 and I have a 1. That means on my list, my x value of 1 would be pointing to a negative 1 and also would be pointing to a 1. Right there, I know that that 1 is going to 2 different places. So I'm going to call that not a function. Remember, the x can only go to one y. All right, and now the last one, when I look across, I do not have any duplicate numbers. So now you can see the trend. If you see a duplicate in that x value, and it's pointing to different numbers on the y range, it's never going to be a function, okay? So here we have a negative 3, a 0, a 3, a 6, a 9. They're all different numbers. So that is a function. Okay, so that is exercises 3 through 8. We're determining whether it is a relation or a function. I'll be moving on to the next section in another video. Feel free to continue on ahead or to go back and complete these problems if you have not completed those problems as of yet. I need my pointer tool. Okay, as always, I am the Miss Peg. Hope this helps. We're on page 108 in Algebra 1 Red Textbook in Alachua County District. Feel free to subscribe, like, and share videos with other students that you know need help in math.